Good morning everybody. Welcome to this new lecture on Introduction to Micromechanical Machining Processes. In the last class we have seen some of the advantages of going for miniaturization components, and those things are the less material consumption, low energy, light devices, increased sensitivities and cost performance issue as well as faster devices. Apart from that, we have seen that what are the different trends in this manufacturing or micro manufacturing processes, and we have seen that there are a lot of devices which are very small in size. So, we have to find out some processes which can be used for fabrication of these components without compromising cost, quality as well as energy requirements. And we have seen the what are the different type of linkage in the machining, so that we can perform a different type of operation without any type of problems. So, all linkage should perform its task 100%, otherwise you cannot get the required geometry or the features on the micro machine components. And then we have seen the different processes, that how the machine also play important role in the fabrication of micro components. And then we have seen different type of applications related to biomedical applications, then aerospace, then watchmaker and jewelry. These are very old age applications of that. Automotives, that what are the different sensors are used in cars and some other automobile for making it more comfort and more safe. The aerospace also we have seen lot of applications, and some other applications were also there related to telecommunication, information technologies and some miscellaneous applications. Now, coming to the classification. Now, we have seen in the last lectures that there are many processes which are used for fabrication of micro components, not only the micromechanical processes. So, we have to see that what are the other processes and where our micromechanical processes are standing along with that in terms of the material requirement or in terms of the processes. So, now first there are many researchers who have classified this process in terms of different aspects. So, we will go through 2 or 3 different classifications, so that you can have a clear idea about the processes which are used presently and how other processes are different from the present processes which we are going to discuss. So, this is the micro manufacturing. Now, there are different type of category. One is the subtractive. So, subtractive processes, that means you want to remove the material from this particular case. Another one is additive. So, here we want to add material, we do not want to remove material. Subtractive processes are mostly related to those processes where we are removing material. So, turning, milling, drilling operation, all these processes, even unconventional machinings also like EDM, ECM, all processes also remove the material. So, all this comes under these subtractive processes. Additive means those processes where we add the components. So, this is the bottom up approach, that means you are starting from bottom and then you are moving from the top, and while subtractive there you are removing the material. So, you are going from top to bottom. Then there are mass containing processes where we do not remove the material, but here in this case we just deform the component to make it in different shapes. And there are joining processes. So, we join 2 different processes. There are different processes available for joining also in micro domain. So, in subtractive processes we know the traditional machining processes, and there are advanced machining processes. Because of the material limitation, we have found some application where we can do machining of any hard materials. In the traditional machining processes, these are well known: milling, turning and drilling, and our focus is also on these processes, but at the microscopic level. Advanced processes, there are many processes like electro-discharge machining, electrochemical machining. So, this is the electro-discharge machining. This is electrochemical machining. Then laser beam, then ion beam, and other than this there are many hybrid processes available. Like So, this is one of the process where it is a electrochemical discharge machining. So, this particular process is a combination of EDM process and ECM process. So, why we need this process? Because we know EDM, it is mostly used for fabrication of conductive material, but there are some application where we can go with the other than conductive material. So, this is called electrochemical discharge machining, or there is another name also there. So, this is called ECSM. So, S means stands for spark. So, electrochemical spark machining. So, that is also one of the processes by which we can get the advantage of ECM process as well as the EDM processes. Similar way, there are other processes available in combination of that you provide a laser beam and then you do a milling operation. So, what is the advantage of doing this thing? So, that when you do machining by milling only, at that time you have to pass through the very hard material. But if you provide a laser beam like that, suppose this is your milling cutter and this is your workpiece, and this is your milling cutter and you are moving in this direction and you provide one laser beam here. So, this particular material become little bit soft. And then you continue machining. So, you do not need to provide more amount of force on this particular milling cutter, less force during machining. So, in that way there are different combination of the processes, those processes are called the hybrid processes. And there are processes like a chemical vapor deposition. Let me clean this part first. So, here this is called chemical vapor deposition. This is physical vapor deposition. This is also one of the process, LIGA. So, it is a German name and it is a combination of lithography, forming, and molding. And 3D printing, there are different names available, those are additive manufacturing, then we can also call it rapid prototyping. So, what is the advantage of additive manufacturing? That you do not need to give additional amount. So, the scrap is very less in this case. So, this is one of the advantage of these particular categories. Now, coming to mass containing. So, forming, casting and molding are the mass containing processes. So, here what we do, that we have a sheet and then we hold this sheet and then we have a punch which will deform this part. So, what we get? We get one type of shape out of this thing. So, why we call it mass containing? Because we are not adding any material, we are not adding or we are not removing anything from out of it, just we are deforming so that we can get the required shape out of it. So, this is the process for forming. A similar way we can use casting also. So, casting, what happened that we use a molten material and we have a mold or the cast, and then we pour everything in this thing. So, it will settle down here, and whatever we are getting out of it, so this is our final product from this particular process. Similarly, molding is also used for the plastic materials, casting is used mostly for the metallic parts. And joinings are also the welding, soldering, bonding. So, these are the processes which are used for joining two different material. But here we are discussing all these processes in terms of micro manufacturing. That means, the dimension or the features characteristics will be in the micron dimension. Then there is another classification. So, again we divide this process into two different groups. The one is the MEMS or lithography based, and there is a non-MEMS. So, here what is this MEMS? So, MEMS is micro electromechanical system. So, this is called MEMS, and this particular subject has a one separate domain which we are not going to cover in this particular case or in this particular course. But these processes are mostly a 2-dimensional or 2.5 dimensional process. If you have seen different type of sensor, accelerometer or some gyroscope in our mobile phone, so those processes are used for fabrication of those small scale components which are mostly the flattened surface, not the Z dimension will be very, very small in this case. And here non-MEMS processes, that means non-lithographic processes or non-lithographic processes, here all the processes which are not used in the MEMS process, that covers in this particular part. So, here one is the lithography process, second is the chemical etching part, third one is the Liga that we have discussed in the last classification also, and there is a plating. So, here main is the lithography process. Lithography process is many things. One is the optical lithography, that is called photolithography. And if you want to go with a very, very high resolution, or we can say the small dimension, then we have to go with the X-ray lithography and the ion beam lithography. And chemical etching is also one there, that suppose you have one component, you want to create this component, this cavity, then you have to take one solid part like this, and then on the top of that you have to provide one mask. And wherever you want this particular thing, the mask will be open from that location. So, this part will be covered with the mask material. So, there is another part, this is the 1, 2, 3, 4 like this. So, these particular locations are covered in one type of inert material. So, this is called mask and this is called substrate, and then you put a chemical on the top of this etchant. So, what etchant will do? Etchant will attack from this particular location, because now etchant can enter and come into contact with this. But here it cannot attack, because this particular material is a inert with this, because it has no any chemical effect with respect to this particular. So, it will start etching this material and you can get some type of material removal from this location. So, ultimately finally you can replicate whatever features you want to design, you have something in your mind or some design parts. So, in this way chemical etching will work, and Liga also we have discussed in the previous slide. Now, in MEMS basis, now here this classification is little bit different, because here the processes which are used for fabrication of a 2.5D processes, 2.5D products, or related to the MEMS product, then only we are discussing. So, here micro extrusion is coming, and micro extrusion is actually one type of forming operation. Okay, then micro injection molding, micro embossing. Embossing is also one type of forming operation. Then micro laser cutting and drilling can be done by these processes, so that we can create some features related to the MEMS product. Then our processes come, that is the micro mechanical cutting operation. So, here our milling, turning and drilling processes come. So, now if you compare the earlier classification, this classification, there are lot of differences, because earlier classification was in terms of the material parts, that what we are going to do with the material. Either we want to remove the material, we want to add the material, we want to contain the mass, or we want to join the material. But this classification is based on the other principle, that we want to just categorize manufacturing, micro manufacturing processes in terms of two parts. One is the lithographic base and another one is the non-lithographic base. So, this is another form of classification. Now, third classification also more or less related to the MEMS product. So, this is called micro system technology. So, micro system technology is also one MEMS part. So, somewhere it is called MEMS, somewhere it is called MST, and somewhere it is called micro machines also. But all three types of processes come under the same domain, that is called MEMS. So, here it is a MEMS product, under is the MOEMS. So, this is a micro opto electro mechanical system. So, this is also, but here objective is to create some type of switching for passing or transferring light source from one location to another location. So, that is called micro opto electromechanical system. By here it is some type of system which can be used for fabrication of different sensors and actuators. Now, what are these processes? Again the same thing will come here. So, here photolithography is there. Other than photolithography, we have ion beam lithography, X-ray lithography, electron beam lithography also. Silicon micro machining, we can do micro machining by etching also, that we have seen in the last slide, and thin film deposition. Suppose now you want to create these features. This is the features you want to create. Then what you have to do, that you create you take out a substrate material, then deposit a small layer on the top of that, and then you can actually replicate the particular product which you want to make it. So, this is where you can do a thin film deposition, and you can create different type of material properties also on some different material, Liga and other techniques which are MEMS based. Then energy assisted, where you are using some type of electrical energy or the mechanical energy to do machining process. So, electro discharge machining process, laser beam, electron beam and focused beam machining. We have discussed this thing in the advanced machining processes in the first classification. And mechanical processes, where we do not use any energy, like in terms of the spark energy or the laser energy, electron energy or ion energy. Here we do a mechanical cutting, that is by means of a physical contact between the cutting tool and the workpiece material. So, these are the three: milling, turning and drilling process. And another process is the diamond turning, which is mostly used for fabrication of non-ferrous material and glass and lens and mirrors and like that. We will cover this process more detail in the later half. Now, other than that, we have seen that we have some processes where we contain the mass, we do not do any type of removal or addition. So, these are called replication techniques in this particular classification, but it is similar to the earlier one which we have seen in the last. So, it is a forming, injection molding, casting and micro embossing. So, these are the processes available. Now, other than that, now what we need something extra. So, this classification gives one another extra part which is more important in this case, because handling is very problematic in the micro component, because once you create a micro component, it is difficult to handle or difficult to move from one location to another location. So, that is the reason this handling is important. Now, how we do handling? That for handling a component, either we use some type of pneumatic chuck or pneumatic handling, so that you cannot physically touch the component, or you create one type of additional feature which is particularly used for handling purpose only, and later on once the component is transferred to the original other location, then what you do, that you remove those components. So, now consider that suppose you have one gear. Now, this gear dimension you consider, it is around 200 micron. Now, you have fabricated, now you want to transfer this gear to some sub assembly. Now, if you transfer directly from here to here, that means by your hand or some other type of gripper, then there is a chance that it may deform or it may break in different locations. So, what people do, that when they are making these particular things by molding or casting, they provide one additional features here, something like this. So, now you are not touching the gear, but you are actually handling by this particular additional feature. For handling micro component. So, now you have transferred to this. So, now suppose now your gear is here, and then you actually remove this thing by some type of soldering, cutting, laser cutting or some other processes, or mechanical just bending, because here contact is very small. So, even if you bend little bit, it will remove from this. So, now your part is ready to perform a sub assembly or the final operation. So, in that case handling is important. Now, coming to mounting. So, handling is done. Now, how to locate that location where it is being assembled in this location. So, at that time you need some type of reference surfaces. That reference surfaces you have to create here, that suppose these are the 4 points. So, you have to align with respect to this 4 point, and then there are some robotic assembly also comes, or some type of pneumatic gripper will come. So, it will hold this particular gear by vacuum and then place it, and then vacuum will be switched off. Then metrology is one of the most important part here, because we know that 200 micron gear, it is difficult to see by naked eye. So, we need microscope each and every location. When you are making this component, you need a microscope. So, what are this metrology consist of? So, there are microscopes, then measurement unit, measurement of dimension, because we know that we want to create a gear with a 200 micron. So, once the fabrication is over, then we have to do measurement, that whether it is exactly 200 micron or not, what is this diameter of this particular part, and what are the characteristics or specification of this particular tooth profile. So, everything should be measured. So, we need some type of measurement unit. So, these are the contact type also and non-contact type also, but mostly we prefer non-contact type, because we do not want to touch this particular component for a later stage, because otherwise it may get some type of scratches or some type of dimensional changes. Then quality control, after all the measurement, we have to see that whether the dimensions and all features are as per our drawing or not, and then quality control person will okay this particular drawing. So, this is one of the way of classification, that in this particular the researchers has added these additional features or additional parameter, that is handling, mounting, metrology and quality control. Now, after this classification, what we have to do, that let us see that how these micromechanical processes are different than the MEMS product. Now, we have seen that MEMS has its own domain related to mostly the healthcare and some type of fabrication of micro actuators, micro sensors like that, and micromechanical machining processes, these processes have their own domain because it can create a real 3D components that was not possible in the MEMS product or some other processes. And here advantage of micromechanical process, because we know the process very well, because everybody knows about the milling machine, lathe machine and the drilling machine, and we know the operations also different type. But MEMS has its different path, because where we do use lithography, etching, deposition techniques, and those processes are not the conventional processes, and we have to create some type of clean room requirement also, and the cost comparison is very different in both the cases. So, let us see that how these processes are, our micromechanical processes are different than the MEMS processes. So, first is the workpiece material. Now, if you see the workpiece material, mostly in MEMS based silicon and some metals, mostly the copper and tungstens are the metal which are used for fabrication of different components. And if you see mechanical, here probably there is no any type of restriction on that. Only thing we have to make sure that our tool should be harder than the workpiece material. So, it covers almost all the things. So, if you see the metal, it covers all the things. Alloy also we can do machining, composite, polymer and some type of other materials which can be fabricated or which can be machined by the micromechanical machining processes. Component geometry. So, here it is mostly a planar surfaces or the 2.5D surfaces. Now, see, this is the one of the components fabricated by the MEMS product by etching and the deposition, different type of lithographic processes. Now, what is this planar surfaces? This planar surfaces means, suppose now you have one plate and it has some thickness. Now, consider this dimension is in centimeter, let us see 1 centimeter, and this dimension thickness, let us consider 50 micron. So, now if you see the dimension difference, it is very large. So, it is in centimeter scale, it is in micron scale. So, basically the thickness is mostly neglected, even though it is a little bit of thickness, but generally you can tell this is the planar surface, or you can say the 2.5D surfaces, because 2.5D surfaces you have a 2D surface, this is y direction, this is x direction, but your z direction has a very small thickness. So, generally we do not consider z as a full, but we cannot ignore also. So, because of that it is considered as a 2.5D component, 2.5D geometry. So, this 2.5D geometry means the z height is very small, or it can be neglected also, and compared to the planar surface, that is called x and y. Other than that, so here in this case you can do a complex 3D component. So, this is one of the component is shown. So, here if you see this dimension, this particular scale is 200 micron. Now, if you see this 200 micron, then this whole thing is probably within 1 millimeter. So, this 1 millimeter you can see that over the features, our eyes is visible, nose, lips, everything is visible. So, it is a purely 3D component that is not possible to fabricate by this type of MEMS product or MEMS processes, that is mostly lithography, etching and all these things. So, that is the advantage of using these particular processes. So, it has a particular application, and these are also a different application for fabrication of this part. So, our objective is to learn that how to create a pure 3D components which are difficult to fabricate by the MEMS product. So, let me finish this class here. We will continue from the next slide in the next class. Thank you very much.